Hello everyone, myself Varshita S from Sri Venkateshwara College of Engineering. Today we will going to discuss about the cloud computing, and the today's topic is the machine reference model. Before going to the topic, we need to know about virtualization. And virtualization is a process that allows a computer to share its hardware resources with multiple digitally separated environments. Each virtualized environment runs within its allocated resource such as memory, processing power, and storage. And now we will discuss about the machine reference model. When an execution environment is virtualized at unlike levels of the stack of computations, then it requires a reference model which defines the interface within the levels of abstractions, and this level of abstractions hides the details of implementations. This project an idea that virtualization techniques can substitute any one layer and can intercept the calls which are directed to it. That's why a clear separation within the layers can simplify their implementations, which only need emulations of the interfaces and proper response with the underlying layer. And this is the diagrammatic form of a machine reference model. It consists of three instruction sets. First one is API, ABI, and last one is ISA. And it consists of hardware requirements, that is hardware and operating systems and libraries and applications. We will discuss about it one by one. At the base layer, the model for the hardware is declared or manifested on terms of an architecture, that is instruction set architecture. First, we will going to discuss about ISA. ISA means instruction sets architecture. It defines the instruction set for the processor, registers, memory, and interrupt management. It is an interface between software and hardware, and it is mandatory for the operating systems developer, like system ISA. Developers of applications whose directly manages core hardware. The operating system layer is separated by the application binary interface from the applications and libraries, which are managed by the operating systems. And the next one is application binary interface, that is ABI. Covers the facts such as low-level data types and call conventions, and it also defines a format for many programs. Mainly, system calls are defined at this level. Moreover, these types of interface enables probability of various applications and libraries across OS which employ the same ABI. Application Programming Interface, that is API, is represented by the highest level of abstractions. This API interfaces applications to libraries and are the core of OS for an action is to be performed in the application level. API, ABI, and the two which are the responsible to make it done. Mainly CPU runs on two privilege levels. That is, first one is user mode and second one is kernel mode. User mode. In this mode, memory access is restricted up to the some limits, whereas access is peripherals is denied. And the second one is the kernel mode. In this mode, CPU has instructions which manages the memory and how to be accessed, and it also has instruction which enable access of the peripherals like disks and network cards. From one running program to another running program, CPU switches automatically. The expansions of applications of computer systems are simplified by this layer approach. Applications of multitasking and coexistence of multi-executing is simplified by this layered approach. The first can be made within the privileged and non-privileged instructions. and those instructions can which can be used within the interrupting with another task are known as non-privileged instructions. They are also called so because shared resources are not accessed. For example, for non-privileged instructions are contains all the fixed points, floating and arithmetic instructions. The instructions which are executed under the particular instructions and which are frequently used for sensitive operations means which expose behavior sensitives or modify control sensitives are known as privileged instructions. And the diagram shows the security rings and the privilege modes. It consists of four rings, that is ring 0, ring 1, and ring 2, ring 3. The ring 3 named as least privileged, and ring 2, ring 1, and ring 0 are known as privileged mode, and the ring 0 is also known as most privileged or supervisor mode. As possible implementation features of hierarchy of the privilege, as we see in the figure in the form of ring based security. And ring 0, ring 1, ring 2, and ring 3 it contains, and ring 0 is the most privileged level and ring 3 is the least privileged level. And ring 0 is used by the kernel for the OS, and ring 1 and ring 2 are used by the OS level services, and ring 3 is used by the users. Recent systems supports only two levels, with ring 0 for the superior mode and ring 3 for user mode. All the current support at least two different execution modes, superior mode and the user mode. The first mode donates an execution mode in which all the instructions like privileged and non-privileged can be executed without any restrictions. This mode is also called as master mode or kernel mode. It is generally used by the operating systems or the hypervisors to perform the sensitive operations on hardware level resources. In user mode, there are restrictions to control the machine level resources. The code running in user mode invokes the privileged instructions. Hardware interrupts occurs and trap the potentially harmful execution of the instructions. Conceptually, the hypervisor runs above the superior supervisor mode. Thank you.